Well, today we're going to continue our discussion of solving quadratic equations that we started the last time. Remember, a quadratic equation must have an x squared. Do y'all remember, what do you call an equation that doesn't have a square? It just has an x, no exponent, starts with L. A linear. And so what we're doing on problem 10, 11, 12, 13, 14, 15, was you're taking a quadratic equation, factoring it, so you have two linear equations. To solve a linear equation, you just get the variable by itself by performing the opposite operation to both sides of the equation. That sounds harder than it really is. So let's look at, this is number 5, okay? Solving quadratic equations. And whoever put this assignment together, whether it was me or my brother, probably included too many videos, okay? But there was one that I think I wanted to include just because we filmed it during when we weren't working. We weren't teaching face-to-face. I don't know what this date is, but anyway, we showed our face the whole time. I don't know what was up with that or why we did that. We might have forgotten we had it on because it looks sort of stupid, if I may say so myself. But there's all the videos, and just by clicking on those, notice I've made a 25 on this assignment, which means if you don't click on them, hopefully, or maybe it's still set to where you have to click on them in order to get to the problems. Eventually that's going to stop, okay? But you still need to click on these so you get credit for them and get the green checks. So let's see. Let's look at problem 2. And you might say, well, wait a minute, you haven't told us anything. No, problem 1 and 2 are exactly what we were doing at the end of class the last time. Solve by factoring. Well, are we going to have just numbers as our answer? Or are we going to have two sets of parentheses as our answer? How do you tell? It says solve, it's going to be just numbers, two numbers. Okay? Let me go ahead and close this door so that my voice doesn't disturb another class, only disturbing y'all. So let's see, problem 2 on this lesson. Well, it's the 4th lesson, but it's the 5th assignment because you have that practice test. Let me write it down. It says solve by factoring. 3n squared plus n minus 14 equals 0. Well, we said in order to solve an equation by factoring, it has to be, in the standard form. Okay? Standard form has the, well, since it's the n squared, n constant equals 0. Is our equation in standard form? Yeah. So the next thing we'll do is factor it. Let's see, numbers that multiply together to give 3. Well, there's 1 times 3, and that's it. Numbers that multiply together to give 14. 1 times 14, and 2 times 7. If your name's not on the roll sheet, just print it, your name on the bottom. I accidentally printed out the same roll sheet for the same class. So, but, okay, so let's try to factor it. I'll draw my 2 sets of parentheses. Hey, do y'all remember the rules for the signs? The second sign is negative. So what sort of numbers multiply together to give negative? Is it going to be positive, positive, negative, negative, or 1 plus and 1 minus? Yep, the second sign is minus, so 1 of each sign. I'll wait to fill it in. Now for 3n squared, I'll just try n times 3n. There's really no other possibility. I'm thinking the 1 and 14 would just get the numbers too big, because our middle term is just a 1n. So, y'all call the 2 and 7? How would y'all put those? Would y'all put the 2 here and the 7 there? Now I'm going to make my little marks for the outer and inner. If we're foiling this out, the first, n times 3n, that gives me the 3n squared. 2 times 7 gives 14, but one of them is plus and one is minus. So let's see. These marks I'm making are for the outer. This is the outer. If I'm foiling out the n times 7, that'd be a 7n. The inner is a 6n. Where's that old table I made that amuses my brother so much? If the second sign is minus, 1 plus and 1 minus, wait to fill it in. To get the middle term from the outer and inner, you're subtracting. Can I subtract these numbers to get a 1n? Yeah, if I subtract 6 and 7, I'll get a 1. So how do I arrange the plus and minus? That student that time that said, we're just making these work out. And that's right. If I want a positive 1n, the bigger number would need to be positive, the 6 negative. That'd be 7 minus 6 to give me a positive 1. So how should I arrange the plus and the minus? What goes in front of the 2? Plus or minus? What should I put to get a negative 6? A minus and a plus? Now foil it out and see. Are you getting a positive 1n as the middle term? We'd have 3n squared plus 7n minus 6n. That would give them combined to give me a positive 1n. And then negative 2 times 7, negative 14. So we have definitely factored it correctly. And now, set each factor to 0. I'm running out of room, aren't I? So we have n minus 2 equals 0. And 3n plus 7 equals 0. So, move this up a little more. Isolate the variable by performing the opposite operations to both sides, beginning with addition and subtraction. The opposite of subtracting 2 from both sides, is that going to be adding 2? So we just have 2 subtract out, n equals 2. So we'll type 2 in as an answer. What about this one over here? How do we isolate the n? First thing I do is subtract 7 from both sides. We showed you a little, that little arrow there is a way you could show subtracting 7. You're moving the 7 over to the other side and changing the sign. So it's just 3n equals negative 7. That's the same thing as just going minus 7 minus 7. Why do I do it like that? Well, it just takes up a little less room on the paper. Just doing this takes up less room rather than showing the plus 2. And what else? Now, the opposite of multiplying by 3 is dividing by 3. So we have n equals negative 7 over 3 and positive 2. So let me come over here. I hope I haven't been timed out. I don't think so. Let's see. I type 2, comma, negative 7 slash 3 and check my answer. Okay? So the first few problems here are factoring. Problem 1, yeah, that one's easier to factor. That's why I just did 2. Then, problem 3. Is this one going to be easy or hard? How the heck did it wind up here? It probably should have been number 1. Okay? This problem, where you have the 2 parentheses equals 0, that's skipping you down to this step right here. It's already done the factoring and everything for you. All you have to do is just, well, I guess it's skipping you down right here. Just take each factor, set it equal to 0. I don't know why Pearson sorted it like that. It seems like that should have been the first problem, now that I look at it. So let me write down problem 3 and do it. Sometimes students have trouble with it just because it's a lot easier than they were expecting. Problem 3. 9b plus 5 times 4b minus 12. Well, I hope you can tell my b's from my 6's. 9b plus 5 times 4b minus 12. On this problem, it's already done the factoring for you and the 0. So you're just doing that last step. Set each factor to 0. And isolate the variable. So that 9b plus 5 equals 0. How would y'all go about solving that for b? Again, these are b's, not 6's. What would y'all do first? Subtract 5, that's right. I'm going to do that. And just move that 5 over and change the sign. So 9b, 0 minus 5, negative 5. And then what to get the b by itself? Divide both sides by 9. The 9's cancel, so we have a negative 5 over 9. What about this one here? We move the 12 over, add 12. And then what do we do? Divide both sides by 4. So we have b, 12 divided by 4. Well, that's just 3. To type this in, notice it says solve. Your answers are, well, certainly y'all would have put 2 sets of parentheses as the answer on this one, when it's already got the 2 sets of parentheses. So the easier way to do this, I think, or the better way, is to type in the 3 first. But I'm going to go ahead and type negative 5 over 9 in. Be careful. If you type that in, it's going to count it wrong. Why? Well, that 3 and that comma should not be in the denominator of the fraction. I'm going to move it like that. I'll move right arrow, and then go comma 3. If your name's not on the roll sheet, just write it at the bottom. I accidentally printed out 2 of the same roll sheet, and then have time to go back and get another one. Okay? Now let's compare and contrast, say, this problem to problem 2. Do they look sort of different? Like here, pretend these are x's. X squared x constant equals 0. What I'm going to show you now is a way that you can solve these when there's just an x squared and not an x. I'm going to do a little bit of writing before I do problem number 4. There's something called the square root property. I'm going to see if you can figure it out before I state it formally, okay? If we had this equation, solve x squared equals 49. Y'all come up with the answer here just by thinking and knowing the multiplication tables. What number can you square to get 49? 7. Suppose I told you there's two answers. Since it's a square, you expect two answers. A positive 7 is 1, and what's the other one? Negative 7. Negative 7 times negative 7 would give you 49. So the answer would look like this. X equals plus minus 7. Trying to show my thought process. How did you get the 49? Well, you took the square root of 49 and put a plus minus in front of it. This method, called the square root property, can be used if you have an x squared, but not an x in the problem, okay? We couldn't really use it on this one here. Like a number 14, no, you couldn't use it because there's that W, and this is number 14 from the last time, okay? So here's the formal statement of the square root property. If x squared equals some number n, then x is plus or minus the square root of n. And that's what we did there. We took the square root of 49, 7, plus or minus. Okay? The square root method requires that there be no number in front of the x squared other than the understood 1. Okay? So on problem number 4, was that 4? I think it was. I should. So look back at number 4. 4x squared equals 8. See, we're going to see we're going to have basically 3 ways of solving quadratic equations today by the time it's over. The first method is factoring. You got that the last time. This method that we're doing here is something called the square root method, and you can use it when there's an x squared but no x. In order to use the square root method, it should just be x squared equals a number. Okay, it's not just x squared, there's a 4 right there. What could I do to both sides to get rid of that 4? I'll give you the choice. Would I subtract 4 or divide by 4? Divide. Divide both sides by 4. And we have x squared. 8 divided by 4 is 2. And then we can use that statement. X squared is 2, then x is plus or minus the square root of 2. Replace the n with a 2. So basically on the left you're dropping the square, so write x, and on the right you stick plus minus square root over that 2. Now can I simplify the square root of 2? No, there's no perfect square that divides evenly into 2. You just got to leave it as plus minus square root of 2. Okay? Plus minus square root of 2. Oh, my brother, get on to me. I shouldn't have circled x equals, because you don't type that in. If you do type it in, guess what? It's going to count it wrong. And for homework, that's no big deal, because, you can then, go back and change it, and you usually get 3 chances before it counts it wrong, unless it's a multiple choice problem. So we did there. I hit plus minus, and then square root of 2. When this first came into existence, this Pearson My Lab, it was basically all multiple choice problems, and then slowly they had to start typing in the answers as the programmers wrote more complex code. But it was only about 10 years ago that they actually had the plus minus key. It used to be you had to use a comma to separate your answer. Instead of the plus minus, you would have to type in square root of 2, comma, negative square root of 2. And you'll see it doing that sometimes when it writes out answers, if you look at view an example or something. But that doesn't mean you need to type it out like that. That's just how it was originally done. I remember the day we were over in that old building in back-to-back classes, and we both were working the same problems, and when we got to the point that there was the plus minus, I was just so ecstatic. I'm embarrassed to say how happy I was that there was a plus minus key there. Now let's try number 5. Oh, wait. Oh, okay. It's similar to number 4. I was about to say it's the same problem. No, it isn't. Okay? No, it is not. Problem 5 says 4x squared plus 8 equals 0. Now, is this something I could do with those square roots like I was doing? Well, yes. How do I know that? There's not an x squared. Excuse me, there's not an x, just an x squared. So, we still need it written just with the x squared by itself. So there's going to be a little bit more to do on this one. To get the x squared by itself, the first thing I need to do is what? Subtract the 8. So I'd have 4x squared equals negative 8. Now it's similar to number 4, except there's going to be a negative. What do I mean? Well, to get the x squared by itself, what do I do? Divide by 4. And we have x squared equals negative 8 divided by 4 is negative 2. I'll do exactly what we did up here. Drop the square on the left. Once you have it in the form x squared equals number, you can drop the square, stick a plus minus square root on the other side. So dropping the square, I'd have x squared. Now this is going to be, see if y'all can follow it. The plus, minus, and square root that I'm about to write are these right here. Plus, minus, square root. The number that's under the square root symbol isn't just a 2. It's negative 2. You know what? I'm going to make this negative green. Well, maybe you can't tell that that's green. Because we're not finished. Up here on this one, we were finished. But because of this negative, you never, ever, ever leave a negative under a square root symbol. What am I going to have to do with that? Well, what kind of number is a square root of a negative? I'll make a math joke and say it starts with I. Imaginary. So this little, because of this green negative here, okay, I've written down the red plus minus. To get rid of this green negative under the square root, I'm going to put a green I and then square root of 2. You'll see why, even though it looks like number 4, is it clear why there's an I down here on this one and not over here? At first I thought I didn't like the fact that the numbers were so similar. Number 5 was so similar to number 4. But no, actually, Pearson, that was a good idea for Pearson to write it like that. This is what I type in. Plus minus I square root of 2. Y'all caught up with me?
Yes.
Any questions? So I'll come up here. I'll type my plus minus. Sometimes students say, hey, they're not showing the I. You just type I on the keyboard, square root of 2. Oh, look at this. It's multiple choice. We'll pretend that it's not multiple choice. I'll hide those choices. It says, solve the equation by the square root property. Oh, wow. You might be thinking, wait a minute, this doesn't look like the square root property. It doesn't look like problems 4 and 5, does it? 3x minus 1 all squared equals 39. Well, notice here, they're being nice, making sure you understand. Don't start pulling this out. This is you can do what we were doing on the previous ones. With the square root property, I said it's got to be x squared equals a number. Well, it turns out anything squared equals a number, you can use that square root property on it. You can do what we were doing here, but you have x squared equals a number. Drop the square, take the positive and negative square root of the number. Right here, just do that same step. Drop the square, so we just have 3x minus 1. Then take the positive and negative square root of that number. Number's 39. Oh, can y'all see that? I'm not up too high. So if it has parentheses squared equals a number, you can still use the square root method. Just drop the square on the left, take the positive and negative square root of the number on the right. Now what about that square root of 39? Do you remember how we simplified that step on day 1 this semester? That wasn't one of our choices here. But square root of 39, is there a perfect square that divides evenly into 39? Like 36 wouldn't divide evenly. By divide evenly, I mean have a remainder of 0. 25, 39 divided by 25, nope. 39 divided by 16, 39 divided by 9, 39 divided by 4. In fact, what's the only two numbers that divide evenly into 39 other than 1 and 39? What are the only two numbers that multiply together to give you 39? 3 times 13. Neither of those are perfect squares. That square root of 39 can't be simplified. Okay? But we're not finished. If we're solving an equation, your answer's got to be in the form. Y'all know what? I can't believe it. I wonder if I would have made this mistake if Tim was sitting right there. Look at me. I feel so stupid. Going from here to here. What did I do wrong? I was supposed to drop the square. I'm sorry about that. I guess I'm glad I saw it. Oh, it's one of those things where I'm trying to correct it and making it look worse. I should be going from here to here. You drop the square on the left, take the positive and negative square root of the number on the right. Drop the square on the left, take the positive and negative square root of the number on the right. This one. I dropped the square on the left. Take the positive and negative square root on the right, but we should have x equals, so we're not finished. How do I get the x by itself? What will I need to do first? Isolating the x. I want x equals a number. Well, how about adding 1 to both sides? Adding 1, or if I just draw my little arrow like that, I'd have 3x on the left, and on the right, 1 plus or minus the square root of 39. There's only one thing left to do to get the x by itself now. The opposite of multiplying by 3 is divide by 3. Now, on our second assignment, when we defined imaginary numbers and complex numbers, we said we had fractions like this, and we said, okay, you break them up, and hopefully you can cancel something. Well, you've got to break it up if there's an I in here. If there's not an I, then there's no way I can cancel anything with this 3 here. Don't say 3 and 39. No, the 39's under the square root. So we just leave it like that. Okay? And let me type. Oh, wait, no, it's not typing. It's multiple choice. Let me see. This is what Pearson, it used to be like. It was all multiple choice. A, B, C, or D? D? Yeah. Okay. Any questions there? So that square root method or square root property can be used whenever you have parentheses squared equals a number, not just x squared.
So you said if it doesn't have an I, then you can't simplify, right?
If there had been an I, you would have to break it up and enter it in. Okay? I'm going to do an example. I'm going to discuss a little bit more that a little more in a moment. Okay? But you're exactly right. If there'd been an I here, you have to break it up. Okay? Else it'll count it wrong. That was one of those changes that they started doing that I didn't like. Another one of these multiple choice problems. Number 7. Oh, is that a Z? It sure is. Z plus 6. Be careful. Z's so often start looking like 2's. S's look like 5's. B's look like 6's. And I realized a long time ago on a test, if there's an S, students are more likely to miss that problem. Because along the way, an S becomes a 5. And then 5S, that's even worse. The 5S becomes 55 and stuff like that. And students miss it. But we can't control the letters here on Pearson anymore. It's not like in the olden days. Okay, so it says you can use the square root property. And can you? Well, yeah. You may not have x squared equals, but you have parentheses squared. So I'm going to, oops. I'm going to drop the square on the left, and on the right, you take the positive and negative square root of the number under there. I mean, on the right. So doing that, I'm dropping the square, so I just have z plus 6. Then I take the positive and negative square root of negative 13. Can I simplify the square root of negative 13? Well, 13's prime, so I'm not going to be able to simplify that. I'm going to have to leave it with the 13. But what about that red negative? Why did I put a red negative there? I'm about to write which red letter? I, right. The square root of a negative. If you leave that negative under the square root symbol, it's going to count it wrong. Well, this one is multiple choice, so okay. But they won't all be multiple choice. So the red negative under the square root becomes a red I. And on the left, we still have z plus 6. What do I need to do to get that z by itself? Subtract 6 from both sides. Or if you're going to say move it over and change the sign, it would be a negative 6 and then plus minus I square root of 13. And questions there. Let me see. There's multiple choice. There'll be some in a moment. Okay. Hey, there's only three choices here. So notice when it says final check, that means that this is your last check. If you don't get it right, you're going to have to say similar problem and do it again. Which one is it? A, B, or C? A. You see, this one here, you don't get 3 guesses. You don't get 2 guesses. You get 1 guess. And if it had been wrong, then it'd give you the similar question option, and you do that one. Okay? Any questions there? That's called the square root method. And right now, we're going to move on to the third method. Problems 8 through 15, and we're going to be using something called the quadratic formula. You see these other 2 methods, well, they may not always work, okay? The square root method, you should only be using that if it's just x squared or parentheses squared equals a number. And the factoring method doesn't always work. The last time we saw some factoring problems that didn't factor, like number 6 the last time. Remember we tried to get it to factor and it wouldn't. And so it's possible that you might get a quadratic equation that wouldn't factor. Here's a question. I'd rather write in a question. I think I'm just going to write out the quadratic formula. The quadratic formula is used if you can't factor it, or if it's not one that's in the form for a square root property. If you don't have parentheses squared equals a number, or x squared equals a number. So here's a formula. It'll solve any quadratic equation. It'll always give you the solutions. Okay? Like if your answers are imaginary numbers, factoring wouldn't give it to you. Right? There's no way you would ever do factoring and wind up with imaginary numbers, is there? No. So here's the quadratic formula. The solutions of the equation ax squared plus bx plus c equals 0 are given by x equals, and what I'm about to write is what people think of as the quadratic formula. It's a big fraction bar. If someone said state the quadratic formula, here's what they're expecting you to say. Negative b plus minus the square root of b squared minus 4ac all over 2a. Negative b plus minus the square root of b squared minus 4ac all over 2a. In order to use that quadratic formula, it has to be in this standard form. X squared x constant equals 0. It doesn't really matter if it's the zeros on the right or on the left. But what I always prefer is for a to be positive. When we were doing factoring the last time, I said it's sensible to assume that that first number is always going to be positive. Okay? And you might say, well, what happens if it isn't? You'll see. You'll see. Okay? So I'm going to make a note. I prefer for A to be positive. If it isn't, I'm going to move it over to the other side to make it positive. Always work out easier. If A is positive, what sort of number do you have in the bottom of the fraction? And this fraction here. If A were positive, then 2 times A is positive. You'll never see fractions written with a negative number in the bottom, okay? That's why you don't want A to be negative. You're just making your work harder for you, okay? Now let's look at number 8. This is the first quadratic formula problem we're doing. It says use the quadratic formula to solve this problem. Let me write it down. Of course, it's y's, not x's. Y squared minus 12y equals negative 31. Well, sometimes students say, well, wait, do I have to use the quadratic formula? Why can't I factor it? Well, if it says use the quadratic formula, that's its way of saying it isn't going to factor it, okay? If you try moving this 31 over, what are the only numbers that multiply together to give a 31? 1 and 31. Will you ever be able to get a 12 out of that? No, with 1 and 31, if you add them, you get a 32. If you subtract them, you get a 30. There's no way you can factor this, solve this one by factoring. So that's why we have the quadratic formula. Could I have done the square root method? No. Why? Minus 12y. Okay? So this one has to be done with the quadratic formula. If you're going to use the quadratic formula, it's got to be in standard form. By that I mean y squared y constant equals 0. What am I trying to say you're going to need to do on this one first before you do anything else? Add the 31. You've got to have a 0 on one side. Usually the 0's on the right, but if it isn't, there's no reason why it can't be on the left. I mean, the 0 can't be over here. And we'll probably see that before this is over today. Before this ordeal that you call class is over. So y squared minus 12y plus 31 equals 0. To use that quadratic formula, it has to be in this form. Well, I used x. X squared x constant equals 0. Y squared y constant 0. Okay. What I do is, once I write it in standard form, I write out the values for A, B, and C. A, B, and C are numbers. Be careful. What's the number in front of y squared? A 1. A, B, and C are numbers. If at any time you find yourself with those as variables, a common mistake I've seen students do, and then they don't know what to do afterwards, or what to do this, they write A as Y. Oh wow, if you start plugging variables into the quadratic formula variables, you're just going to get a big mess. A, B, C are always numbers. B is the coefficient on Y. Be sure to include the sign. B is a negative 12. And C is a positive 31. So you write it out in standard form. And you know what? I'm not going to try to correct this, but this looks like I have a decimal point there, doesn't it? Well, If I do that, is that just making it worse? Now it really looks like a decimal point. A is a 1. There's no decimals here, okay? B is negative 12. C is 31. Now I'm going to write out the quadratic formula. Negative B, since it's on the other page, I want to have it right here looking at it. Negative B plus minus the square root of B squared minus 4AC all over 2 times A. So I'm plugging into this quadratic formula. Everywhere there's an A, you're going to put a 1. Everywhere you see a B, you're going to put a negative 12. Everywhere you put a C, or see a C, put 31. So I'm going to get started. I'm drawing my fraction bar. Now this says negative B. Well, B is negative 12. So we have 2 negatives. We have the a black negative and a red negative. Did y'all hear that? That's going to be a positive 12. Y'all see why I wrote a positive 12? The black bar is the bar from the formula, the negative from the formula. And then negative, there's my red negative, making it plus 12. Then I'll write my plus minus. Now, generally you want a calculator to help you with some of this multiplying and so forth. Ooh, let me clear this out. B squared, I always suggest you do that either in your head but don't show a step for it. Sometimes showing too many steps is messes you up. Negative 12 squared. What's negative 12 times negative 12? Positive 144. So I'm just going to write 144 in place of the B squared. Now, a word of warning about this. Sometimes students tell me, oh, the calculator's messed up. If you punch this into your calculator, and this is true for most calculators, it gave the wrong answer. Wait a minute. We know negative times negative has to be positive. If you're going to square a negative number on a calculator like this, you've got to put the negative in parentheses. Right, negative 12 in parentheses squared. So 144. Okay? So I've been meaning to, or wanting to mention that, and now seems an appropriate time. Don't rely too much, or don't press the calculator too much. You've got to make sure the order of operations, the exponent applies only to what's right beside it. So the thing that's right beside it is a 12. The negative isn't right beside the exponent unless it's in parentheses. Here, the thing that's right beside the square are the parentheses. So you have 2 negative 12s. Okay? Or what you might want to do is just, okay, you know negative times negative is positive, so just square the 12 if you don't know the 144. So what I do, I square the B. Now I'm going to say minus 4 times A. I'm going to replace A with a 1 times C. I'll replace C with a 31. If you want to use little stars or something to indicate times instead of the parentheses, that's fine. And just like I do the B square in my head, I highly encourage you to do the 2A in your head. Instead of writing 2 times A, you can do that in your head. If you replace the A with a 1, 2 times 1 is 2. Let's just write a 2 down. Now, I'm going to simplify under the square root. Okay, I'm going to simplify under the square root. I'll draw an arrow here. I'm going to punch in, let me clear out this so it's not so busy. I'm going to punch in what I have written there. 144 minus 4. You can either say times, or if you use a parentheses like I did, 4 times 1, A times C, 4 times 1 times 31, a 20. So we now have a square root of 20. Right there. By the way, 4 times 1 is 4. 4 times 31 is 124. 144 minus 124 is 20. You can do this in your head. You don't have to use a calculator. I'm just trying to show my thought process. Now, can I simplify square root of 20? Some of y'all have little calculators where if you punch in square root of 20, it'll simplify it for you. Others are like mine. How do I simplify square root of 20? Is there a perfect square that divides evenly into 20? Again, going back to the first day of the semester, looking through our list of perfect squares, only one of those numbers divides evenly into 20. What is it? 4. So I'll think of this as, I think I'm too much red. 4 times 5, so square root of 4 times square root of 5. That gives me a green 2 and a blue square root of 5. Think about math. That's different from a lot of stuff. The way it builds. We just did what we were doing on day 1. Okay? So now I'm going to rewrite it, replacing all of this with 2 square root of 5. Okay? So I'm also going to put it all in one color. Now 12 plus minus, instead of all this circled stuff here, we'll write 2 square root of 5 all over 2. And there's a couple of ways to reduce this. If your answer has an I in it, if you have an I here, then you've got to do the separating. Okay? If it doesn't, the way I prefer to simplify it is to look at the 3 numbers that are not under the square root symbol. 12, 2, and 2. What can I divide all 3 of those numbers by? A 2. If I divided this 12 by 2, I'd get a 6. If I divided these 2's by 2, I'd just get 1s. So let me just make a note of how I'm doing. Am I going to have a fraction in my answer? 12 divided by 2 is 6 plus minus. 2 divided by 2 would just be a 1. And I don't have to write a coefficient of 1. I can just write square root of 5. 2 over 2 is 1. Do I need to write over 1? No. Just 6 plus or minus the square root of 5. Okay? 6 plus or minus the square root of 5. That would be the final answer. Probably missing those multiple choice. No. So we type a 6, then a plus or minus the square root of 5. Now I said if there were an I, you split it up. Well, if we had split it up, would we have gotten the same answer? 12 over 2 is 6. 2 square root of 5 over 2 is just square root of 5. So you would have gotten the same answer. Okay? But I just want to mention reducing fractions. if we had something like this, let's see, I made up some examples. Okay. 8, suppose you had this, 8 plus or minus 14i square root of 5 all over 4. How will we reduce that versus this one here? 8 plus or minus 14 square root of 5 all over 4. Okay. The only difference between the two fractions is this one has an I. If there's an I, you've got to do what we were doing on that second assignment. Separate it like this. So it'd be 8 over 4, then the plus minus, 14i square root of 5 all over 4. This is how we reduced those fractions on the second assignment called complex numbers. I think it was problems 3, 4, 5. When you break it up like that, 8 over 4 we could write just as a 2, then plus minus 14 over 4. What could I divide the 14 and the 4 by? A 2, so it would be a 7 in place of the 14, and in place of this 4, a 2. I could divide both of these numbers by 2, so we'd have a 7i square root of 5 all over 2. If when you're using the quadratic formula, you wind up with an I in your answer. To reduce it, you've got to break it up like this. Now, if there isn't an I in your answer, then I'd simplify it the way I did up here. Like looking at 8, 14, and 4. What number other than 1, or is there a number other than 1 that divides into all of these? 8, 14, 4? That's the only number that divides into these three numbers. A 2, so divide each of these three numbers by 2, and your answer is going to sort of look different from this one up here. That's what I'm wanting to show. So you'd have an 8 divided by 2, 4, plus minus. What number is going to be in front of that square root of 5? 7. 14 divided by 2 is 7, square root of 5. And then on the bottom, 4 divided by 2 is 2. Pearson, the reason I'm mentioning this is Pearson used to let you use this method when reducing the imaginary numbers. So your answer would wind up 4 plus or minus 7i. For this one, they don't let you do that anymore. If you punch this in, a big fraction, rather than separating, it counts it wrong. Okay? One of those changes that I don't think is necessarily a good change. I don't have any control over that. Okay? Are we ready to try another one? Let's move on to number 9. Let's see. Number 9. 2x squared minus 7x equals 1. Let's use the quadratic formula. 2x squared minus 7x equals 1. So there's something I need to do to this to get it going. I've got to subtract that 1. I need a 0 on one side of the equation. So it's not in standard form until I move that 1 over. So we'd have 2x squared minus 7x, and then a minus 1 equals 0. Now is it in standard form? Yeah, it is in standard form. So let's write out A equals, B equals, and C equals. A is a positive 2. B is a negative 7. And C is what? Negative 1? Every time I do a quadratic formula and I see a problem, I write down the formula, and I suggest you do that too. Okay? Negative b plus minus the square root of b squared minus 4ac all over 2a. Let's write it down, the formula. I think I'll do it in purple. Negative b plus minus the square root of b squared minus 4ac all over 2a. Okay. So to get started, if I replace the b with a negative 7, what's negative 7? Positive 7. That negative b just means change the sign on b. Since b is negative 7, negative b is positive 7. Then plus minus, oops, I grabbed the wrong color. Square root, okay, b squared. What's negative 7 times negative 7? Y'all know that. You don't need to use a calculator. 49, okay. Then a minus 4 times A times C. 4 times A times C. All over 2 times A. What's 2 times A going to be? 4. A is 2, so 2 times A is just 4, so I'll just write that down. Sometimes showing too many steps just bogs you down. For the small stuff, the 2 times A and the B squared, just do it. Don't write it down. Don't add an extra step. Sometimes adding too many steps just makes it worse. So now what am I going to do? I'm going to simplify under that square root. 49 minus 4 times 2 times negative 1. Punching a negative, here's where my negative is. On my calculator, on most calculators, there's subtraction keys and there's negative keys. Okay? 57. 4 times 2 is 8, times a negative 1 is negative 8, minus a negative would just be 49 plus 8. So you can do this in your head if you want. 57, can I simplify square root of 57? No, there's no perfect square that divides evenly into 57. So we'll leave the square root of 57 as it is. Write down 7 plus or minus the square root of 57 all over 4. Since there's not an I here, I do the little divide thing, and there's no way. There's not a number in front of the square root, so we assume a 1 there. 7, 1, and 4. Is there anything I can divide those numbers by? No. So there it is. 7 plus or minus the square root of 57 all over 4. This quadratic formula will solve any quadratic equation. Oh, I like it when it says this. The solutions are x equals, it writes it for you. For such a messy fraction, I'll use this little fraction hot button and type in 7, then a plus or minus square root 57 all over 4. Any questions on that? Let's jump around. Let's jump to number 12. I'm looking for one that has an I in the answer. Isn't, I'll have to look again. So number 12. X squared equals 6x minus 18. X squared equals 6x minus 18. Is it in standard form? No. In order to use the quadratic formula, it has to be written. The equation has to be written like this. Ax squared plus bx plus c equals 0. Or theoretically, 0 equals ax squared plus bx plus c. You want the 0, or you want one side of the equation to be 0. I want the a to be positive. So I would not move the x squared over to the right and get the 0 here. It'll always work out easier if that x squared term is positive. So what I'm going to do, I'll just use my little marks. Move the 6x and the minus 18 over. Here's the equation written in standard form. X squared minus 6x and plus 18 equals 0. Well, I dimmed these lights, which I should have done a long time ago. I just noticed how pale the screens are. Now, write out A equals B equals C equals. Be careful. A, B, and C have to be numbers. Don't write A equals X. Right. Let's see, what's it going to be? A equals, it's going to be 1. Are y'all caught up? Or are y'all ahead of me? A equals 1. And what's B? Negative 6. And C is positive 18. Now, I'll write down the quadratic formula. I'll write it down every time. Negative b plus minus the square root of b squared minus 4ac all over 2a. Let's see. Well, heck, I guess surely eventually we'll have a problem where b turned out to be positive, but it's once again negative. So what's negative b? Positive 6. Negative, negative 6, positive 6, plus minus the square root. B squared. What's negative 6 times negative 6? 36. Then we'll write minus 4 times A times C all over 2 times A. Can we do the 2 times A in our head? I sure think so. 2 times A, 2 times 1 is Is that going to be a 2? What am I about to do now? Simplify under that square root. So let's see. So we have, where's my calculator? We clear it off. 36 minus 4 times 1. I don't need to write that times 1, but I did anyway. Times 18. And negative 36. Pardon me, oh wow. So we have a negative 36 under that square root symbol. Can I reduce that? The square root of 36 is 6. What am I going to do with that red negative? The square root of 36 is 6. Because we have a negative sign under the square root symbol, it's going to be an imaginary number. Now rewrite the fraction, replacing all of that square root with just 6i. So we have 6 plus or minus 6i all over 2. Now this one has an I, but you're going to get the same answer whether you split it up or if you just divide it. Like each of these 3 numbers you can divide by 2, but I'm going to show splitting up because that's what they want you to do when there's an I. We'd have 6 over 2 plus or minus 6i all over 2, which leads us to what answer? 3 plus or minus 3i. Good. 3 plus or minus 3i. 3 plus or minus 3. I'll use that I, or you could use keyboard I. Okay. Any questions? Okay, we'll do 13, 14, 15. Let's do 13. Okay. Under 13, r squared plus 3r minus 6 equals 0. Is this in standard form? Yeah, we don't need to move anything around, do we? Okay. So, r squared, r constant. So, let's write out a equals, b equals, and c equals. Who wants to call them out? A equals 1, very good. B is 3, and C is negative 6. Good. I'll write down the formula now. Negative B plus minus the square root of B squared minus 4AC all over 2 times A. And I'll just start plugging in here. All the examples we've done so far, B was negative. So I wanted to find one where B was positive. So if b is positive 3, what's negative b? What am I going to write there? Negative 3. That negative b just means change the sign on b. So you have a negative 3 plus minus, let me draw my square root symbol, and I encourage you to do the b squared part in your head, and if you can't do it in your head, then a calculator. 3 times 3 is 9, okay, so 9 minus 4 times a times c, so minus 4 times a is 1, c is negative 6, all over 2 times a. What's that 2 times a going to be? 2 times 1 is 2. Okay. What am I about to do now? What are you about to do? There's really only one step now. One correct step right now. Yeah. Let's punch in 9 minus 4 times 1 times negative 6. The 4 times 1 is 4. Or I guess you could say negative 4 times negative 6. That would be a 24. So it's 9 plus 24. You want to do it by head, in your head? That's great. But it's sort of hard for me to show my thoughts in my head of what I'm doing. It looks like I'm just popping the answers out. So 9 minus 4 times 1 times a negative 6. The number under the square root is a 33. So I'm replacing all of this.
Can you switch it to your notebook?
Oh my gosh, thanks. Oh, how long have I been talking? Okay. So let me go back. The negative 3 is just, minus b is just negative 3. Plus minus the square root, 3 squared, 3 times 3 is 9, and minus 4 times a times c, all over. I do the 2 times a in my head. 2 times 1 is 2. Next, I simplify under the square root symbol. 9 minus 4 times 1 times negative 6. Oh gosh, thinking of younger days. Used to be a teacher here. She didn't write on the board. She'd stay here and do what I just did to y'all. She'd talk you through it without writing it on the board. I remember once her saying, oh, I got bad student evaluations. And I was like, write on the board. Write on the board. Well, they did have all of this. This was literally in the 90s. Okay? But so I was doing to y'all what she used to do to her classes. Any questions on how I'm about to put a square root of 33 in place of that square root there? This is square root of 33. Can I simplify the square root of 33? Nah, 3 times 11 are the only numbers that multiply evenly into 33, or that divide evenly into 33, and those are not perfect squares. So we have negative 3 plus minus square root of 33 all over 2. Can I reduce this in? No. There's no I, so we just, okay, what number divides evenly into 3, 1, and 2? Well, nothing but 1. So we leave it like that. Click in here. Sometimes students say it doesn't show the little box, the tools. You've got to click inside the answer box before it shows you those. And we go negative 33 plus minus the square root of 33 all over 2. Any questions there? Can I follow what we're doing? This quadratic formula will solve any type of quadratic equation. Number 14. Let me write this down. Negative 3x squared equals negative 5x plus 10. Negative 3x squared equals negative 5x plus 10. Check to make sure I did it. We've already done one problem that's similar or is sort of in the same format. Number 12 that says x squared equals, and we moved everything over here to the left and put the 0 on the right. It really doesn't matter which side the 0 is on. What matters is a little statement that I wrote in red right here. I prefer for A to be positive, and that's my gentle way of saying you should prefer it too. It'll work out easier if those fractions aren't negative. Like right here, if you had a negative 2 there, it would want you to go through and simplify it some so that you have a positive number on the bottom. Okay? So, with that in mind, how does number 14 differ from number 12? Number 12, I'm put the 0 on the right by moving these things over. That's not what I'm going to do here on number 14. If I move the 5x and the 10 over, I'd have a negative. A is negative. Don't want that. So using my little marks, right there, what am I saying I need to do to get this in standard form? Add the 3x squared. That's going to give me a 0 on the left, and that's fine. Okay? I mean, you don't really, if I move this 3x squared, we have a positive 3x squared, then a minus 5x, and a plus 10. You don't really do anything with that 0. Okay? It doesn't really matter if the 0 is on the right-hand side of the equation or on the left. Okay? How do I decide where to put it? Well, I want that x squared term positive. Any questions on how I've rewritten this and what are my values for A, B, and C? A is a positive 3. B is negative 5. And what's C? Positive 10. This will work out easier than if you had moved these stuff over to the right and had a negative, A is negative 3, B is positive 5, C is negative 10. If you did it with A equal negative 3, you're going to wind up with a negative number in the denominator, and then you're going to have to get rid of it and rewrite that fraction with a positive denominator. Okay? So let me write down the quadratic formula. Negative b plus minus the square root. Am I showing my work? Okay, good. B squared minus 4ac all over 2 times a. So just every time you use the quadratic formula, write it down, and you'll have it almost memorized. Okay? So let me write this. Let me draw my fraction bar. Negative b. B is a negative 5, so negative, negative, will that be a positive 5? Any questions? Are y'all caught up? Is this just hitting you in the face at this point? Okay, b is negative 5, so I'm looking at negative b, so negative, negative, okay? So we have a green negative and a blue negative. That's why I'm writing this plus. This part here is green. It's hard to tell up there. Everything looks black to me. This part here, the up down is the blue for that one there, and blue negative. Plus minus the square root b squared. Negative 5 times negative 5. What am I going to put in place of b squared? 25. Then minus 4 times a times c. So minus 4 times a is 3. C is 10. All over what? Do the 2a in your head. 2 times a, 2 times 3 is 6. See, if you had moved the stuff around the other way and you had a negative 6 down there, you've just created more work for yourself, because you need a positive number on the bottom there. Okay, let me simplify under the square root symbol. Patch that into my calculator. Let me clear off my calculator. Okay, so it's 25 minus 4 times 3, which is 12, times 10, 120. So it's 25 minus 120, negative 95. Negative 95. Right now you can answer this question for me. Will there be an I in your answer? Yes. Okay. And what about 95? Can we simplify square root of 95? Where's my list of perfect squares? Oh, wow, I just love the way I can do this. Back in the olden days, writing up on boards, I could have, look back at what we did on day 1, you know. I love this. Here's our perfect squares. 95 divided by 81, 95 divided by 64, or 49. Maybe 25, but no. 95 divided by 25, that wouldn't go evenly, would it? 25 times 4 is 100. 25 times 3 is 75. So I'm just talking enough to see if I can convince you that we can't simplify the square root of 95. But what can we do? In place of this blue negative here, I'll put a blue I. And the square root of 95 just stays square root of 95. Now let me write it all in one color. Make it look a little cleaner. We have 5 plus minus I square root of 95 all over 6. If there were no I in your answer, you'd be done here. And Pearson used to let you type this in, and it would take that as an answer. Then one summer, they do updates to the whole program, and big updates in December and June. One June, we come up here, and it no longer lets you leave it like that. What do you have to do? Separate it. 5 over 6, then plus minus. Notice you can't reduce 5 6. I square root of 95 all over 6. And just out of curiosity value, I'm going to see what does it do if I typed in that first answer before I separated it. It used to take that answer. If you typed in 5 plus minus I square root of 95 all over 6. Let's see. Is it going to take it or not? It did. I'll be darned. Well, maybe they'll start back taking all of them like that. Okay? So I remember complaining to the Pearson rep about that. So that is really good. Okay. Huh. Okay, so you see it, let me take, that one. Okay? Rather than this one. In the past, it's always wanting it like that. But no, in the recent past. Last year, it wanted it like this. 2 years ago, it let you punch it in either way. Okay? So maybe they've gone back and fixed that coding. Okay? Any questions there on number 14? We're about to do number 15, and it's the last one, so it has to be the hardest one. What do you think? Does it look a little bit more involved than the others? Yes? Because of what? The fractions? Here, before I do this, I want to review something. I'm going to review how to multiply fractions. If you're thinking, why on earth is he doing that? Well, just bear with me, okay? If we had this, 2/3, I'm going to use a dot for times, 2 over 3 times 9 over 5. 2 over 3 times 9 over 5. There's two ways that you can multiply fractions. The basic definition of multiplying fractions says just multiply straight across. So we'd have 18 over 15. There's another way you can multiply them, and that's the cross-canceling method. You can either go multiply straight across, you get 18 over 15, and then you can reduce this one by dividing above and below by what? 3. So it would be a 6 on top and what on the bottom? 5. That's the basic definition. A over B times C over D is A times C over B times D. What else? Another way you can do these is to cross cancel. Looking at the 2 and 5, there's nothing that divides evenly into those. Looking at the 3 and 9, is there some number that divides evenly into both of those other than 1? 3. If I divided 3 by 3, I'd get a 1. If I divided 9 by 3, I'd get a 3. Then multiply straight across. By doing that, you skip this step and go straight to the 6 over 5. This is called cross-canceling with multiplying numbers. What if we had something like this? 5 times 3 over 10. 5 times 3 over 10. Well, you might say at first, well, wait, that 5's not a fraction. Sure it is. You can make it as 5 over 1. Could I do some cross-canceling on this? Not on the 1 and 3, but the 5 and 10? What can I divide both of those by? 5, so 5 divided by 5 is a 1. 3 divided by 10 is a 2. But 3 divided by 10, what did I just say? 5 divided by 5 is 1. 10 divided by 5 is 2. Now multiplying straight across, we just have a 1 times 3 over 1 times 2. So one of the fractions that you're multiplying is just a whole number. You can just put it over 1 and make it into a fraction. What about this? 24 times 5 over 12. So 24 times 5 over 12. Yeah. I would think of the 24 as 24 over 1. And how would I cross cancel? 12 goes into 24 twice. Are we going to have a fraction as our answer here? No? It would just be what? 2 times 5, 10? So, when multiplying fractions, it's possible to cross cancel, or maybe you can cross cancel the denominator so you don't have a fraction anymore. Let's go back to number 15. Wait, first of all, agree or disagree with me? This stuff here isn't that hard. Agree? Okay, it's not that hard to multiply fractions. Remember, addition and subtraction are more involved because you've got to have that common denominator. Let me write down number 15, and I'm going to spread it out a lot. Because I'm going to rewrite this equation so we don't have any fractions. X squared plus 1 over 10x minus 1 equals 0. 1/2 x squared plus 1/10 x minus 1. See, theoretically, this thing's in standard form. Nothing in the quadratic formula says that you can't have fractions for a, b, and c. Okay? I didn't say they can't be fractions. So if you want to say a is a half, b is 1 over 10, and what would c be? A -1? Then go for it. I'll tell you, it's going to be a little messy plugging in those fractions. What I prefer to do, if we have an equation with fractions like this, is to think about multiplying. With any equation, you can multiply by whatever you want, both sides, as long as you multiply every term. If I wanted to multiply every term here by 7, even the 0 I'd have to multiply by 7, and the 1 times 7, I can do that. But multiplying by 7 wouldn't cross-cancel both of these denominators. Can y'all think, if I multiplied straight through by 2, if I put a 2 over 1 right here, I'd cross-cancel this denominator, and I'd be rid of the fraction here. But would a 2 work for this one? If I put a 2 here, I'd cross out the 2, but the 10 becomes a 5. What number could I multiply straight through by that'll cross-cancel with both of these numbers? Not a 2. What if I put a 10 here and here? 10 and 2, do I have a fraction then? If I multiplied straight through by 10. Even the 1 gets multiplied by 10. Am I showing my work, or are y'all looking at a screen? Okay, goodness. If I did that, multiply straight through by 10, do both of my denominators cancel? I think they do. Right here, 2 goes into 10 5 times. So So would this all be just a 5 and an x squared plus, right here, would this denominator cancel? That's what I want to do, is rewrite this equation so we don't have any fractions. By multiplying, in this case, I'm multiplying by 10. Is all of that canceling? And we just have a 1x or x. Y'all are very silent. Is anyone following this?
Yes.
Yeah. Okay, now if you're going to do this, you've got to multiply every term, even this 1, we have to multiply by 10. So instead of a minus 1, we have a minus 10. And theoretically, even zeros being multiplied by 10. 0 times 10, though, is still 0. What I've done is rewritten the equation, and what I think will be an easier way to do the quadratic formula. Instead of a is a half, b is 1 over 10, and c is negative 1, we have a equals, let's write it out. A is 5. B, there's not a number in front of the x, so what am I going to put there? A 1, there's always a 1 there. B is 1, C is negative 10. So if everyone's number 15, it's going to have fractions. So it'll just be a matter of you figuring out what number can I multiply straight through by. Well, you've got to be able to find one because there's infinitely many. Like I multiplied by 10, but theoretically if I multiplied by 20, 2 goes into 20, the denominators would have still canceled. We'd have numbers that are a little bit bigger, but no fractions. Okay? So writing down the quadratic formula now. You can multiply both sides of an equation by any number other than 0. Why would you multiply it by 0? Because then you're going to get rid of everything. So plugging into the quadratic formula, y'all caught up. Y'all see why I got a equals 5, b equals 1, c equals negative 1 over 10. I think that's going to be easier to plug in than a equals 1/2, b equals 1 over 10, c equals negative 1. So let's see, minus b, is that just going to be a negative 1 plus minus the square root b squared? What am I going to replace b squared with? 1 squared is 1. And then here comes the minus 4ac. Minus 4 times a times c. All over 2 times a. What number am I going to have on the bottom here? 2 times 5.
Is your 10 still negative?
Your
10, your C?
Oh, thank you. Oh, gosh. I would have really messed up and been there trying to figure out what did I do wrong. Thank you. This C here should be a negative 10. And let me correct that. I'll put it in red. Okay. And did I mess up anywhere else? The bottom number, 2 times A. Do I have that one right? Well, let's now simplify under square root. That's going to be 1 plus 200. Let me clear this off. So we have 1 minus 4 times 5 times a negative 10. 201 Are we going to have an I in our answer?
No.
No. Okay. Let me get this out. Oh gosh, perfect squares. That divides into 201. I started going through divided by 100. No, that's not going to go even. 201 divided by 81. No, 201 divided by 64. I'm just going through the list of perfect squares. Started like with 100, going back. Does 64 divide evenly? No. 49 doesn't. 36 doesn't. 25 doesn't. Y'all can tell me, just stop if you're convinced. Square root of 201, are we going to be able to simplify it? Ah, there is no perfect square that divides evenly into 201. So actually, is that making it harder or easier? It's easy. I just replace all of this with square root of 201. So I have negative 1 plus minus the square root of 201 over 10. Okay? This idea of multiplying both sides of the equation by a number to get those fractions to cancel out. That might be a fun chore for y'all to do. Try it with a equal to half, b equal to 1 over 10, and c equals negative 1. And see how long it takes you to get it. So what is it? Negative 1 plus minus the square root of 201 all over 10. Okay. Now, if I said similar question, I'm not going to do it, but just tell me, what do I need to multiply by? Generally, here's how you can figure it out. If the bigger number will cross-cancel both of those, wonderful. If not, just multiply them together, the two denominators together. Here, 20. Okay, that'll do it. But let's see, on this one, what do y'all think you would multiply by to get this? A 14, would that cross-cancel both of the denominators? Yeah, okay. Now, sort of see what I'm doing there, or saying there? Oh, we finally get this. What do y'all think you would always say? Say best score or save this attempt? Best score. If you click save this attempt, you've lost the green check on this one, and you're going to have to do it again. Right? There. Okay. Any questions? I'm going to stop the recording, and I will see y'all on Wednesday.